Okay, for today we are looking at part 2 of section 3.4, a little more work on equations with lines. So we're now looking at day 2. This will be pretty brief, just a few examples I want to go through with you guys to add on to what we said in the last one. So we're still looking at writing equations of lines, but one of the differences we're going to see today is how do we do that by looking at a graph. And so if I look at line R, that's this guy right here. So we are looking to come up with the equation of line R. And guys, typically we're going to be using slope-intercept form. If you ever are asked to write the equation of a line and it doesn't specify which form to put it in, this is our go-to form, right? We want to put it in slope-intercept form, which means I need to know two things, the slope and the y-intercept. And if you can figure that out just by looking at the line, take advantage of that, because sometimes you can and sometimes you can't. But let's see if we can identify both of those just by looking at the line. So for my slope, here's line R. Let's see if we can figure out, just using rise over run, what the slope of line R is. So let's just identify two obvious points on the line. Right, so I want to pick two clear points on that line and simply count rise over run. You can see this is going up 1 over 1. So that's simply our slope is 1, or 1. You could say 1 over 1, but we tend to simplify that and just call it positive 1. Always check to make sure that you have the right slope. Keep using that slope and make sure that you're still on the line, because sometimes we can miscount a little bit. But if I go up 1 over 1, up 1 over 1, up 1 over 1, as I keep doing that, I can see for certain I'm still on the line, right? So I'm pretty safe with 1 over 1, so that looks good for the slope. How about B? B is the y-intercept. So here's my y-axis. So where does line R intercept the y-axis? So if I look at that point right there, nice and clear, that was up 1, 2, 3. So at positive 3, I have my y-intercept. So this one's nice and simple. I get to go straight into the answer. Remember, this is y equals mx plus b. So mx plus b. So there's the equation of line R. And you don't have to put the 1 there. If you just wrote that as y equals x plus 3, all right, we always know there's an implied 1 in front of any letter that we have in an equation. Let's take a look at line S. As I look at line S, looks like we should be able to figure this one out. Pretty simple as well. I'm going to show you something on line S for a situation that you might run into, but let's just start with the slope. Typically, in a line, you should always be able to count the slope. You shouldn't have to use the formula when you're looking at a graph. So I'm just going to pick two nice clear points to work with. I'm going to go with him, and he seems to be my next obvious point. And it looks like my slope here is down 2 over 1. So I'm going negative 2, right 1. So my slope for this guy is negative 2 over 1, or you could just say negative 2. Check to make sure that's consistent. Pick another point. Down 2 over 1 looks good. Down 2 over 1 looks good. Down 2 over 1. So it looks like we're pretty safe with that slope. How about the y-intercept? Now on this one, again, I can tell what the y-intercept is, right? It's right here at positive 2, right? And so if you can tell what the y-intercept is for sure, go with it. Because sometimes you can tell. Sometimes it's like it'll hit like in between like this, and you can't really tell what it is. And so I'm going to show you the other method for figuring out the y-intercept if it's not clear by the graph. So let's just take a point on this line. I'm going to pick the point 2, negative 2, this guy right here. I'm going to use this as just any old random point on the graph, 2, negative 2. If I couldn't tell what the y-intercept was, this is what I would need to come up with in order to get the equation, because this is what we did in the past lesson. I have a point, I have a slope, we're going to plug into point slope formula to get our equation, right? So I'm going to say y minus my y coordinate, which was negative 2, equals my slope, times x minus the x coordinate, which is positive 2, And so that gives me this, and as we already saw in the last lesson, if I get y by itself, I have the equation of my line. So let me do a little cleanup on that. Do a little distribution over here. And subtract my 2 from both sides. And I get this guy. So, and sure enough, y-intercept was positive 2, just like we expected it to be. But like I said, sometimes by the graph you can't tell because it's in between the lines. You know, if it's something like this, you're not going to know what that number is, right? And so you have to do this process in order to come up with the equation that you need for this. Okay, and so now you've seen it, super doable. All right, last two, we need the line parallel to line R containing this point. So let's go back to line R for just a minute. What do we know about parallel lines? Parallel lines have the same slope. So what was the slope of line R? It was 1. So if our lines are parallel, then our line is going to have the same slope. And so all we know is its slope. We know a point on that line. And so we're right back into what I just did in the previous problem. We're going to use point slope in order to get the equation of the line. So I'm going to say again, y minus my y coordinate, which was -1, equals my slope, times x minus the x coordinate. So there's my setup in point slope form. Let's get y by itself. Clean up right there. Distribute on the right. Gives me this. And now if I subtract 1 from both sides, we get this guy for the equation of our line. So this line is parallel to line R, and it would also, if you graphed it, it should pass through this point right here. All right, last one. Real similar, but now it's perpendicular. So if I go back to line S, the slope of line S was -2. So what slope is perpendicular to -2? So remember, how do we get a perpendicular slope? We got to take our fraction, we're going to change the sign, so it's going to become positive, and then we're going to flip it, right? We do the reciprocal. So if this is 2 over 1, if I flip it, it becomes 1 over 2. And so that's the slope we need to work with. So now we have a slope, we got a point, right back into point slope, y minus my y coordinate equals my slope, times x minus the x coordinate, right? This was x1 and y1. Let's clean up a little bit. Let's get y by itself, distribute on the right. Remember that I showed in the last video, at the end of the last video, if you're ever concerned with using a fraction, I showed you a way of getting rid of the fraction. So you could do that here. I could multiply both sides by 2 and get rid of my fraction. The only reason I'm not doing that on this problem is because when I distribute, he's actually going to get rid of himself, right? Because when I do half of 2, I'm going to get a whole number. I'm not going to still have a fraction, right? So before I forget to apply it to my x as well, so as I distribute, so half x minus, and we know half of 2 is 1, right? And so that one really worked itself out. We didn't need to try to get rid of the fraction. When I go to add 3 to both sides now, it'll add in nicely to him. And this is where we would finish. So always looking to end in slope-intercept form unless the directions tell you something else. But that is it for this section.